All right, well, I'll just go from here. Hi, my name is Akeem. I'm at Cloudflare now. I'm an engineer here, but I've been EM at various startups, also done a little bit of comedy and all that. And so I just wanted to really talk about something that has been a huge productivity boost for me when I'm working on front-end applications. But I wanted to kind of go beyond a specific library or tool and just sort of talk about some of the concepts behind it. And so, title of the slide, teaching my AI to see. So I've got a little robot who's being taught to read, but it's kind of going on making it more self-sufficient, much like a child in elementary school. And this is kind of loosely what I'm talking about. Like as I mentioned, I wanted to, if you're not too familiar, get a little background on some basics and talk a little bit about like testing history, some principles, how this actually works, because I think one of the big factors in being more productive in the AI code generated, or the code AI generates, is just kind of understanding like, why does this work in Siri? Like if I was just to do this manually, like how would I visualize it for myself, and how do I just multiply that? And then talk a little bit implementation, kind of move it around. And so I added this definition here just to kind of ground and differentiate agentic workflows versus merely using AI-assisted coding. And so I've spoken to colleagues who are using AI. They kind of fiddle around with it, but it's not having that productivity boost that like everyone was promised. And I wonder what the disconnect is. And so if you start off, that dictionary definition, an AI-driven iterative process where autonomous agents use reasoning, planning, and tools to complete complex multi-step tasks without constant human oversight. And the important part of that definition is that it is an iterative process, and you get the agent to be completely free to perform the manual task that you would normally perform in like that human in the loop interaction. And so what does this actually mean in practice? It's easy for me to visualize an old school Roomba that just kind of like vacuums, and then it like bumps into a wall, and then it vacuums, and it looks pretty dumb, but eventually it gets everything clean. And I don't know if you've ever kind of peeked at what the modern AI coding tools like Claude Code or Cursor are doing, but a lot of times it doesn't get things right the first time. It kind of writes some code, it checks it against a linter or something like that, it realizes it's wrong, or it runs some tests, it realizes it's completely wrong. And if you leave it to its own devices, eventually it will get it right. But I think part of the modern development workflow is kind of adding these guardrails so that even if the tool hallucinates completely, you'll eventually get to a right solution. And so if you're not familiar with the concept of tools in AI, they're basically a mechanism for the AI to interact with your computer. From basics, it will be reading and writing files, but ultimately, with the right permissions, it can run any arbitrary code. And so MCP servers are common use where you have access to remote resources, but the most powerful tool of all is that a lot of AI coding tools have the ability to run bash, which means you can basically run anything. So if you leverage things like skills, then you can say like, oh, this is how I run like this command line tool or the set of command line tools. It really doesn't matter how you do it, because anything you can theoretically do with a computer, you can do with an AI. And so for things like command line and APIs, that's a little bit straightforward because these are always have been intended to be machine readable. But I think really the big breakthrough is given that you have the ability to run this arbitrary code, you can run like linting, you can run like tests, you can format, you can do whatever. But there are also ways where machines can interact as humans, like we've done this before. And so think about how we test as humans, how we develop as humans. Early in my career, when I was writing code, it kind of resembled this GIF. I fiddled around with something, I tried to reproduce a scenario, and I ran the code, it didn't work, rinse, repeat. That got really annoying. You'll find out pretty quickly as a developer that if you don't write any automated tests, after a while you're going to have a bad time. And so collectively, we've realized that, okay, if you write the test once, then you don't have to go through the work of setting up these scenarios over and over again. You can run all these different scenarios. You can make sure you don't break anything when you change it, and you'll have a much more streamlined situation. And so when kind of talking to people and seeing how they were using some of these AI tools, it actually kind of resembled early version where the AI would spit out some code. It would look completely broken and they'd like try to like fix it. It'd spit out more code, they like fiddle with it, like they check it's working, like they open up Chrome and it's like, wait a minute, this looks 90% right, but not quite there. Go back to the drawing board. But similar to how you would think of it as a human, I think it's very constructive to think of it in terms of how you can automate it with AI. And so, the TLDR, use Playwright. I think that's simple for the web use case. And if you're not familiar with Playwright, it is a pretty mature, battle-tested framework for writing test cases against user behavior in a browser. And so it's an established way to kind of automate, instead of using the CLI, if you wanted to reproduce a user going to a web page, clicking on a button, and you expect that everything turns red or something like that. It's kind of like an established way for us to do that historically as engineers. And so when working with AI, you can use it with an MCP server that's pretty popular, or you can just use it from the CLI. It has all these different interfaces to work with it. And traditionally, test engineers or people who just wrote end-to-end tests would write things in JavaScript or Python, test specs, which were basically, hey, click on this button, expect this thing to happen, and that would allow you to run it over and over again and have the confidence to know that things didn't break. But what the huge breakthrough for me is that Playwright is actually pretty good when combined with AI of doing this manual testing where you have this code, you don't quite know what's going to happen. Let's click on it, let's see what breaks, let's take a look at the logs, and it can have a holistic view of, hey, the user performed this action, this thing happened in both the console logs, this thing happened on my server logs, and then instead of you going and doing these things manually, similar to if you wrote automated tests, it can iterate on that quickly. And it will be like, oh, yeah, like I completely hallucinated that function, let me fix that. And so that is something a lot of people in the backend take for granted, in that you can easily verify like whether an API exists, you can just curl it, you can make an API request. But that has historically been a little trickier with human interaction because people don't interact like machines. But with frameworks like Playwright, we kind of bridge that gap between acting like a machine and interacting like a human. So this is very basic, but I had it have a bug where I was working on a side project and I was like, oh, this is huge. It's not right. It's supposed to be like a login screen. And so I told it to use Playwright, and I was like, okay, run this to, and maybe that went a little too quickly, so I'll pause. And I asked it to run the web server. For context, I'm working on a side project where it's just like a personal CRM, like a anti-social network where I keep my whole Rolodex of contacts, but I don't bug them to connect on LinkedIn or whatever. And I was inspired to use a framework that someone presented a few months ago, Tamagui. It's React Native. It works in web, it works on iPhone, Android, but not quite the same. And so I will have something that I developed something for Android and it looks fine there, but completely broken when I do the web version. And as I work on features, I have a flow where I just have it validate as part of the process. Hey, run these commands, do it, and it will actually just click through things like a normal user. It knows what the app is supposed to do, and so it will act accordingly. And then when it encounters an issue, it will actually address that directly instead of waiting for me as a human in the loop to give it permission or like tell it what to do. And I really think that's extremely powerful and unlocks a lot in terms of being able to have things hands off and you can do something else entirely and only kind of talk to it with larger architecture decisions. Like if something is obviously broken, you can use tools like Playwright so that your AI can actually see and interact like a user and do some of that exploratory testing that you would normally have to do manually and then automate it. And so ultimately, going back, going back to the automated testing, I've actually been also using a flow where the first step of manual testing to just make sure it works, I have AI create it in Playwright. And because it's already speaking that language, I then get it to write the end-to-end test, and it's able to, without even using AI in general, I can also validate on my own that everything works as expected as I develop new features. But another huge advantage of Playwright is that it hooks into the browser's development tools. And so when you're making requests to the backend, it can see the network requests and it can be like, hey, like I see what these requests are. Let me go ahead and make some traditional integration tests where I can set up a mock server using the actual backend code or like simulations of the backend code. And so you can get pretty advanced with your testing, and so you can validate even scenarios that you didn't even know you needed to address, and do it in a way that is systematic, where you're not even really relying on AI. You can use traditional tools and principles. So I did that. So one of the big unlocks of using AI in this matter is that you're essentially describing the behavior you want to see and validating against that behavior. And it sort of sounds a lot like test-driven development when you say it like that. And so it's kind of crazy because this is sort of like the pinnacle of also behavior-driven development, where you describe a user behavior and you're kind of building towards that goal. And previously, there have been many frameworks that have attempted to kind of make it look like natural language, but ultimately you had to write code. But since the AI can translate, hey, here's a spec, here's what's supposed to do, and actually like perform the actions and realize, oh wait, it doesn't quite work that way, like this is how I represent this programmatically, you actually have an easy way to do this for free. And I think I've always been kind of a little loose with test-driven development. I've not been super strict, but I do like that it focuses on the intended outcomes and not on the actual implementation details itself. And what's great about that when using it with an LLM is that I've sometimes noticed that if you just do a straight unit test, the AI will kind of cheat and it will like mock the code to do what the test was supposed to do. Like if I had a sum function and 2 plus 2 is 5, then it will like mock the same, change the mass subprocessing thing so that it somehow works to 5. But with end-to-end tests, since you have more of a black box where the AI doesn't necessarily control the implementation as much, and it's focused on the outcome, it's harder for it to cheat with those things. And so your tests become a little bit more meaningful. And ultimately it kind of creates like a better tight feedback loop around the design behavior. And so I mentioned that especially with front end, people haven't been as good with the testing. And just to give a little bit of history, there used to be like a concept of a testing pyramid. Like you would have unit tests, which were just testing functions, where you call like this one function and it's change color, like it returns red, or like 2 plus 2 equals 4. And that's very easy and very cheap, but users don't actually call functions directly, and so there are many layers in between calling that actual function where you're very confident about the function, but like if your button is completely broken and not attached to it, then it's completely meaningless. But it's cheapest, but not high fidelity. As the tech improves and as we've gotten to invent tools like Playwright, where we're hooked in more to the user browser experience, there was kind of a shift in the industry to have more like behavior-driven tests. And so like if you've ever used something like React testing library, the whole philosophy behind that is that your implementation doesn't matter. From a user's perspective, they click the button and it turns red. It doesn't matter like how that happens, and really you don't care. You may change the implementation entirely. But again, there is still some mocking involved there, and so it isn't the highest fidelity. And the best and most realistic thing is an end-to-end test with something like Playwright or in the past Selenium. But those were kind of flaky at times and very expensive because you would have to you have to figure out exactly what to do to click it and get it in the right thing. And so it might take an entire engineer entirely to write those tests. But with AI being able to not only do this exploratory testing on its own, but also write the code for the test specs itself, then this has actually changed dramatically. The economics completely shift, where you can have the confidence of doing at least one end-to-end manual test as just part of your development flow, but you can also get the more cheap and reliable integration and unit tests for basically for free. And so I've adopted a flow where, hey, I have the AI do it, but part of the validation is whatever it is that it needs to validate, whether it's curl or it uses the browser, it uses it as the end user, gets that experience, it will experience the bugs that come up. It will see it in its logs. It can fix them, can address that loop, but also I can, for later, as it's building upon more features, just programmatically run the cheaper test as well. So going on next. And so I mentioned Playwright, but I think this concept applies more to other tools as well, depending on what kind of application you're developing. And ultimately, what you have to ask yourself is, what is the user experience? What is the user behavior? And how can I mimic that behavior? And so if it's a browser, Playwright is the best appropriate tool. Maybe there will be something else in the future, but you just need to understand the concept. The browser, the behavior interface, how do you validate it manually? But I recently worked on a project where we had a collection of Lua scripts and like 20-year-old code that we wanted to port, and there were no tests, and I was basically like, here's the code. If you curl all these endpoints, this is what should happen. And it like goes to these upstream things and proxies, and in that case, like, hey, curl is the best interface because as like a proxy server or whatever, it is just pure straight network requests. And so really you have to think about like the audience of what it is that you're building. But second example, unfortunately, I didn't get a demo video of this. As I mentioned, I was working on a side project. It was a React Native app, and when I first had the AI build it, it was completely broken entirely. Like it just like errored. It looks correct, but like there were just errors on every screen. And so thinking through this concept, if this was web, I'd use Playwright. But if I were testing this app manually, I would use the iOS simulator. So I looked, okay, like how do I use the iOS simulator with Cloud Code, whatever? I found an iOS simulator MCP, and using that MCP, the AI was able to realize, okay, now I can see what's going on in this app. Now I can tap on these buttons and see this error in my console. Oh, once I did that and I saw the error in the console, it immediately knew what it hallucinated and it was fixed in seconds. And so that saves me a bunch of time of like trying to figure out how to debug each screen individually, which can take forever potentially, depending on how much slop you've written. But if you allow it to check itself, then you can get pretty far. So yeah, like I also validated the backend with curl and logs, and the same concept. You choose the interface that your consumers are using. And so yeah. So key takeaways, you really want to just tighten that feedback loop. You just provide the agents with a way to call themselves out when they're bullshit. And even with the current impressive state of models, they still occasionally hallucinate. But like the Roomba, if you provide enough guardrails, it doesn't matter. Like eventually everything will get clean, like as much as it bumps around. And so for web development, JavaScript specifically, Playwright is a great tool, very mature framework for browser interaction. But ultimately think about engineering principles, like how does this work? Why does this work? How can you validate that this thing does what you say it does? And think about the interface. And I think that's me, but yeah, any questions?
I have a question.
Yeah.
Have you thought at all about, I've done some stuff with Playwright testing, but have you thought about storing the intent of the test in natural language so that when the test inevitably flakes or fails, the LLM is able to then repair the test in place so that it can keep going?
So what I have found when I have the LLM write tests, like when you, in JavaScript, TypeScript particularly, I like the kind of jest style where you have a describe block and like it will kind of describe that in natural language. And for better or worse, the LLMs also are pretty verbose about adding comments. And so usually with each test case, there is like a natural language description of like what's going on. They're non-deterministic, so your results may vary, but like I find, at least because I tend to write my test cases that way and I have those examples, that they end up saying what it's supposed to do in natural language. So
Nice.
I want to say that it does that by default, but who knows? Maybe with the next model, it just does something, does it in Hindi or something. But that's a good point.
Hmm.
And maybe a follow-up to that, maybe different. I understand, and I also use Playwright, so I can understand how to set it up
Mm-hmm.
to test what I have today, or what somebody has today, but the software is changing. The UI that you have today is changing from today to tomorrow.
Mm-hmm.
So any hints how to set up, I guess, the application itself, so it's easier to test as we change it. So we can identify the elements easier. For a button, you can do a button review,
Mm-hmm.
but the more complex changes that happen to the UI, how do you preserve your tests over time?
Yeah, and that itself could be its own talk, but one thing I mentioned was the idea of like behavior based. And so I really recommend reading up on like the React testing library philosophy, because it is more of a focus on, instead of choosing different IDs and like traditional class names and all that stuff that we've done in the past, it is more on, if you think of it from an accessible way, the user isn't just clicking on a form input field with the ID name. It is clicking on something with the label name and typing in stuff into there for whatever the closest input. And so a lot of these newer libraries try to be more high level, and enable that kind of like high level, like this is the behavior that we're trying to test versus the implementation details of the UI. And for me personally, like when I've just done those types of tests in the past, those tend to be more resilient to UI changes. And so, give an example, you have a calculator app and you have the test in that the user presses the 1 button and then they press the 2 button and they press like the submit button, and it ends up being 3. And it isn't like the specific ID, it's like what is labeled or what has that text, and based on like user perception than the actual implementation details, and that tends to make it more resilient. One thing I do like about also using the LLMs is that if something breaks, then because you've also described it in human language or in terms of user behavior, then the AI is actually pretty decent of saying like, okay, like I need to perform these actions, how do I convert that into code? And so you can actually set up like even a pipeline where if something is break, it investigates what is broken and see if it's like a variation of, hey, something is actually broken in the code, or do we need to make our test more resilient? And so when I've worked with Playwright in like refactoring some things, it's actually done a decent job of like noticing that, surprisingly. Does that answer your question, Noah?
So you can just a follow-up is, do you capture like human description, like human behavior with the app?
That's what I usually aim to do with like the both the like describe and it blocks in JavaScript, but also I tend to have like comment blocks in between sections of what it is it's asserting, and that usually kind of guides not only the human beings reading the test case, but like the LLM that's working on the code.
Yeah, okay, cool.
Yeah, you were talking about a couple different layers. One being that an LLM will reach for unit tests first. It'll usually write it poorly. I definitely have the skill for you, a skill library. But what I found is you can prompt that out of it with a skill, and then coupled with the skill is a rule. I don't know if you're familiar with the rules, but like you can basically auto load a skill based on a glob. So you could go and do like a test pattern, load your generic skill, and then load your contextual like repo, call it a skill, within that as well. And that's pretty much hammered it out for me. Like, I don't like unit tests in general, so like I feel in the testing trophy philosophy. So like all my tests are basically all mostly integration and then a layer of end-to-end for like the main flows and things like that. But then if you can layer the skills, you can actually tune it to write tests almost exactly as you might write, which is really helpful for getting to that kind of like I don't want 2 + 2 = 5 plus stub, like always stubs everything. Is you could basically say like don't ever stub anything unless you absolutely have to. I found that to be pretty helpful. But the other one is, I think it was Joe, did you know this? Was the Playwright CLI over the MCP, and the reason is you pay the context tax every time you start a session with MCP, whereas the CLI you pay that context tax when you use it. So it ships with a Playwright CLI skill, and that skill will only load the skill like definition and everything like that when you're actually working in a test, which is quite nice because otherwise what I found when I was using MCP servers is like I like start it and it's like 100,000 tokens used, and it's because it loaded the entire MCP server spec at the start. So that can at least help with like the efficiency and like token spend and things like that. But
Yeah, I didn't have any opinion given on whether the MCP or CLI is used. I do tend to use skills more because of the token efficiency, but the good thing about it is that it's such like a large and mature library that both options are available. Because even I've kind of discovered command line arguments just from watching the AI do things. But yeah, like use CLI, use skills. I think really mainly the concept high level is just providing that interface, like using that interface that connects like the machine readable stuff to like human interaction. But yeah, that's a great call out. All right.
Awesome.
Thanks.